partial fraction method, and by using this partial fraction method you have to find inverse Laplace transform. Suppose you have given some function n of s, which is given in the form of rational p of s divided by q of s. Okay, and one more assumption is that degree of p of s is less than degree of q of s. Means p and q both are polynomial. P and Q are both are polynomial, and we are assuming that degree of P of S is less than degree of Q of S. So we will consider a different cases. Okay, for a first case. So while applying partial fraction method, suppose the first case as when roots of Q of S equal to 0 are real and distinct. Already you are studied. I am going in different way. I am going different way. I am going to use the result. That's why I'm explaining. Suppose I will assume that let S is equal to A, B, C, D dot 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 are the roots of are the roots of Q of S equal to 0. Then can anyone explain how I can write Q of S? If not, I will explain. Yes, anyone? Suppose you are having x square minus x minus 6 equal to 0. What is the degree of this equation or this polynomial? Ritesh, what is the degree?
2, sir.
Yes, degree 2. So there are two roots. What are the roots? Can you identify? X is equal to? Roots means the value of x which satisfy the given equation. Hmm? What are the roots?
2 and 3, sir.
All of you agree? 2 and 3? Minus 6 you have to split.
Just wait for 1 or 2 minutes. That internet connective issue I am facing. I am joined by my mobile. I think I am audible now.
Yes, sir.
What I am discussing, when A, B, C, D are the roots of any equation, then what are the factors? That is my question. What are the factors? Yes.
What are the factors? Just a minute. Okay, what are the factors? Now this part I will remove. Today we are having disturbance. What are the factors? That is my question. I think already you have studied that partial fraction method in different way. I am going to explain the formulas. Sir, if you are having A as the root, then first factor is S minus A. If B is the, yes, Omkar. Omkar Khoti, want to say something? Or by mistake it happened? Onkar Khoth. Hello, I'm audible now. Onkar,
Yes, sir.
Onkar Khoth. You are using hand raise option. Any issue is there or anything you want to ask? Onkar. Okay, it may not be there. So A is the root. Then corresponding to that, we are having S minus A as the factor. In the same manner, B is the root. B is the root. Then corresponding to that, S minus B is a factor. Similarly, we can take S minus C. Yes, Onkar, any issue? Like that, we can continue. Okay. So if these are the factors, then how? Then I will write this n of s as the numerator. Okay. The numerator, that is p of s, remains same, and this q of s I will replace as the factor s minus a, s minus b, s minus c. I think already you have studied. The same thing by partial fraction method, anyone can explain what is the representation in this case. One thing you can notice, any factor is non-repeated. All are the linear factors. Yes, anyone? I think Siddesh Walke. Siddesh, are you there?
Yes, sir.
How to represent this as a partial fraction? You can refer your notes. I think already you have studied. Quickly, if you don't know, then tell no, sir, I don't know. I will shift to the next one. Siddesh, what is your opinion?
Don't know, sir.
Okay, Ayush Salunke. Hmm. What is the representation of this ratio as Ayush, I think you are not audible properly. Ritesh,
Yes, sir.
hmm. How to represent this?
Sir, A upon S minus A plus B upon S minus B.
Yes, very good. Very good. Very good. It can be represented as A upon S minus A plus B upon S minus A. So like that, continue. Just wait for 1 minute. Just wait for 1 minute. Okay. So how we are going to represent further? It can be written as B upon S minus B plus C upon S minus C. If further terms are there, we can represent. Okay, that is a continuum. Now, I think for finding the coefficients, you may using the cross multiplication and you are comparing the coefficients. So here I am going to explain the formula to calculate the constant. Suppose our aim is to find the first constant A. So where the coefficient A is given by, what you have to do? You have to take n of s. Okay, n of s. That means this term as it is. This term as it is. Now this term you have to multiply by the factor which is in the denominator of that arbitrary constant. What is that constant? Is s minus a. You have to put s minus a, and value of this term at s is equal to a. value of this term at s is equal to a. In the same manner, suppose if you want to calculate the next constant b, so what will be the result, Ankita?
N
In the
of
same
S
way,
into S minus B.
very good. N of s into s minus b, and value of this function, that line stands for at s equal to b. Similarly, suppose if you are finding c, then n of s multiplied by s minus c and value of this function at s equal to c, and so on. In the same manner, further you can calculate the term. So this is the first case. Now the second case, first case what I am discussing here, first case what I am discussing, that roots are real and distinct. Suppose the second case I will consider. Case number 2. Case number 2. I think you have studied this these results in different way, maybe, right now? Case number
Yes.
2. Case number 2. What happened? Some roots may be repeated when the roots are when the roots are real, real and multiple. Okay, means what I will assume, suppose s is equal to a is the root of that q of s, and which is repeated n times. That means let q of s is given as s minus a, because this root is repeated n times, multiplied by some q1 of s. And what is my assumption? q1 of a is not equal to 0. Means what? That is not a factor of the remaining. Then in this case, n of s is given as p of s divided by q of s. I will replace as s minus a raised to n into q1 of s. Now remember, here I am explaining or I am demonstrating only for the repeated factor. That repeated is s minus a raised to n. Now it can be written as what I will write. Same notations you have to use. A naught divided by, start with that same factor raised to n, and in each step what you have to do, you have to reduce the order of that factor by 1, plus a1 upon s minus a raised to n minus 1, plus a2 upon s minus a raised to n minus 2. I will continue till you will get a linear factor s minus a, and at that time what will be the term? What is the suffix for a? It is n minus 1, plus some p1 s upon q1s. Okay, that means this term this term may be converted or maybe comes in the earlier case. That earlier case you can apply. Now in one formula you can find all the coefficients, where where the coefficients where the coefficients are given by a general formula. Or first I will write a naught. Suppose you are finding a naught, then a naught is given by, so before that I will calculate one term. What term? So let I will calculate a new term, some n1 of s. How this n1 of term is calculated? N of s multiplied by s minus a raised to what? You have to cancel that factor s minus a raised to n and the remaining term. That is the term. Okay. Then the constants are given by, first a naught is given by value of n1 s at s is equal to a, and next one is a1 is equal to derivative of n1s. You have to find first derivative of n1s. After finding the derivative, you have to substitute s is equal to a. Next, the term a2 is given by 1 upon 2 factorial second order derivative with respect to s of n1s, and this is at s equal to a, and so on, and so on. Now it is difficult to remember all the results. So in general, single formula, I will generalize that. In general, in general, this, in general, this an minus 1 is given by 1 upon n minus 1 factorial into n minus 1th derivative. Okay, n minus 1th derivative of n1s, and value of this function at s equal to a. Now in this formula, if you put n is equal to 1, you will get a naught, because 1 minus 1. If you put n is equal to 2, you will get a1. So like that, continue. Okay, like that, continue, and so on. Okay, only the particular cases I am taking when the roots are real and distinct, and when the roots are real and multiple. If the quadratic factor is there, we will go in the regular way. Okay, I will take an example and you will get more clear idea about this. So remember, when the root is repeated, this is the general formula. Okay, or any other method which you have studied in 12th, that you may continue. Okay, that you may continue. So let us continue with the example. So today I will consider this example as a number 1. Find inverse Laplace transform of, find inverse Laplace transform of 2s square minus 4 divided by, so directly factors are given, 2s plus 1, s minus 2, and s minus 3. Okay, instead of polynomial, factors are given. Now I will consider the given term first. So let 2s square minus 3 divided by s plus 1, s minus 2, s minus 3. Now I will ask some question. Now you are having two polynomial. Numerator is one polynomial, denominator is also one polynomial. What is the degree of numerator? Ritesh?
Sir, 2.
Very good. Degree of numerator is 2, and degree of denominator? Apia?
Sir, 1.
1.
Hmm? Degree
Sir,
of
then
denominator is 1. Yes, Afia. It is
sir
1.
2.
Huh. Yes, yes, you unmute and tell me, na.
2.
Okay. Okay, come to Ankita. I think you are having problem. Ankita.
Yes,
Here,
sir.
degree of denominator.
3.
Yes, degree of numerator is 2. Degree of denominator is 3. Means 2 is less than or equal to 3. So if this condition satisfy, then only we can apply partial fraction method. Means this term I will write by using partial fraction method. Sum a upon first factor. Factor may be, that arrangement may be different. Your factor may be s minus 2 first, s minus 3 first, like that. So I will write a upon plus b upon second factor is suppose s minus 2 plus c upon s minus 3. Okay. Now we have to calculate 3 constant, where first constant a is given by.
Yes, sir.
So what I told, for first
S
example, I will
square
write it.
minus 4.
Whatever the term is given, that you have to write as it is. That means 2s square minus 3 divided by,
Minus 4.
Hello, sir. 2s square minus 4 actually.
in the statement. Okay, thank you. This is 2s square minus 4. Yeah, 2s square minus 4. So here also I have to correct. It is 2s square minus 4. Okay. Now denominator is s plus 1, s minus 2, s minus 3. So what I did here, if you come to the theoretical part, so this term I am taking as it is n of s. Now for that term, you have to multiply by s minus a. Why I am taking s minus a? The constant which you are evaluating in the denominator of that factor is there. But in this case, for our example, what is the factor? Anyone, what is the factor? You are calculating a. You are calculating first constant a, and in the denominator this is s plus 1. So you have to multiply by which factor? Anupam? Anupam? Which factor you have to multiply?
Yes, plus
S plus
1.
S plus 1. बरोबर आहे, छान. S plus 1, and after multiplication value of this function at s equal to किती येईल विपुल? Now this factor, Vipul, can you tell s plus 1 equal to 0? Then what is the value of s? That is a question. What is the value of s, Vipul?
Yes, sir.
Raj? Yes, Raj?
-1, sir.
Very good. S equal to -1. Vipul सांगितलं का? S equal to -1. Yes, correct. S equal to -1. Okay, this part I will remove. This part. Now here you can notice this s plus 1 factor and this s plus 1 factor get cancelled. Now for the remaining terms, you have to substitute s is equal to -1. That means 2 into -1 square minus 4 divided by -1 minus 2. It is -3. -1 minus 3. It is -4. What is the evaluation of numerator? What is the evaluation of the numerator? Ishika, I will highlight the term. Yes. What is the evaluation of the numerator?
-2.
-2. Okay. -2. And what is the evaluation of the denominator?
12.
12.
Once again, the constant a is equal to, what is the final answer? -1 upon 6. Okay. -1 upon 6. That is the first constant. In the same manner, suppose if you want to write b, can I write b directly here? So ultimately what you have to do, from the given function, you have to cancel the factor which is present in the denominator of that constant which you are finding. Now in this case, the factor is s minus 2. That means I will skip s minus 2. So the remaining is 2s square minus 4 divided by s plus 1 and s minus 3, and value of this function at s is equal to Vardhaman. Vardhaman, I am right now?
Yes, sir.
किती येईल? You have to evaluate this value at s is equal to, what is the value? What happened? S is equal to 2. Smith, that is correct. All should attentive. Otherwise, write in the chat box. I will collect the answer. S is equal to 2. Few names purposefully I am taking. Because in this case, you have to put S minus 2 is equal to 0. That means S is equal to 2. This S minus 2 factor, कुठून येतोय? इथून येतोय. Okay? ठीक है? Now, चलो. So if you evaluate 2 into 2 square, 2 into 2 square minus 4 divided by 2 plus 1 is 3, 2 minus 3 is 1. Okay, that answer I am getting in the chat box. B is equal to minus 4 by 3. Write everyone in the chat box. I will go with the majority. I will enable the chat box from my end. Okay, minus 4 by 3, Susmit. Next. So this implies B is equal to only one answer. Everyone should write in the chat box. Okay. Neeraj 0. No. 2 चा स्क्वेअर 4 होणार 4 दोन्ही 8 8 minus 4 minus 4 by 3. Neeraj check. Okay. Yes, minus 4 by 3. Okay. This answer is minus 4 by 3. Very good. Very good. Good response. B is minus 4 by 3. Now the
So,
next. Yes.
sir, actually, that partial method is more convenient. Means we have the practice of that.
Now you can
So,
continue with that. Means you are
this is
multi.
new concept, so it is
No,
taking me.
it is better because why? What happens directly in the formula you are getting that part, na? That's why.
Huh.
No calculations here. Otherwise, what happens? You are equating, multiplying. First, you are taking cross multiplication. After that, you are equating the coefficients. You are getting simultaneous equations like that, na? Everyone,
Yes,
tell me
yes.
which method I should carry.
Sir,
If you
just we are habitual with that.
no,
This is
it's
new,
okay.
so it will take time
No.
to.
Okay, it's okay. One suggestion is we will go with the regular method. What about others? If you fail the regular method, we will go with that also.
Sir, this is okay, sir.
Which one? Old method is convenient
You are taking that one, sir.
because what happens? These are the formula. Just directly you are getting the answer. That's why I'm taking this one. I feel this one is easy because what happen in case of a repeated repeated simultaneous equations are getting, but here direct you are getting the values. One more example I will take. You will get clear idea in that. Okay, I will continue. See, suppose now the C constant C is given by the constant C is given by 2s square minus 4 divided by I should take s plus 1 and s minus 2. Is it okay? And value of this function at s is equal to 3 because in this case the denominator factor is s minus 3. Okay, already calculated some students. So 2 into 3 square, I will write the term. 2 into 3 square, that is 9 minus 4 divided by 3 plus 1 is 4. 3 plus 1 is 4 and 3 minus 2 is 1. And if you evaluate this, C is equal to, now everyone write in the chat box, only one. Sasmi said C is equal to 7 by 2. Yes, S is equal to 3 or to put. Yes, 7 by 2. 7 by 2. Very good. Okay, very good. It is 7 by 2. I will continue with that. So C is given by 7 by 2. That is your third constant. Now all the values I will substitute in the formula. All the values I will substitute and I will write the inverse Laplace. Therefore, little bit I will scroll up. Therefore, L inverse of 2s square minus 4 divided by s plus 1, s minus 2, s minus 3 is equal to L inverse of, I will write the term by substituting that. A is minus 1 by 6 upon s plus 1 plus B is minus 4 by 3 upon S minus 2 plus C is 7 by 2 upon S minus 3. Now here I will apply linearity property. Minus 1 by 6 can be taken common. L inverse of 1 upon S plus 1. Minus 4 by 3 into L inverse of 1 upon S minus 2 plus 7 upon 2 into L inverse of 1 upon S minus 3. Okay. Now further if you simplify, this is minus 1 upon 6. Unmute and tell me. L inverse of 1 upon S plus 1.
E raised to minus 1t.
Minus 1t, that can be written as minus t. Very good. Minus 4 by 3 into e to the power
E raised to 2t.
2t plus 7 by 2 into e to the power
3.
plus 3t. Okay. So that is your required answer. If you want further, you can simplify. Okay. If you feel that earlier method is easy, you can continue with that. Any method you can use to find the constant. So one more example I will take and I will stop. Suppose second one. Second one, find inverse Laplace transform of 1 upon s minus 2 bracket square into sorry, s plus 3. Okay. Now consider, I will ask some few questions, then tell me. So I will write the given term as it is. A upon s minus 2 bracket square into s plus 3. What is the degree of numerator? What is the degree of numerator? Polynomial is constant. What is the degree?
0.
0. Very good. And what is the degree of denominator? It is 0. Denominator degree? Denominator degree? Yes, it is 3. It is 3. So once again, degree of numerator is less than degree of denominator. You can apply partial fraction method. So this example totally new to you because this is repeated. Little bit concentrate on this. Now, for this repeated factor, you can compare with that. So what is the practice? You have to start with a naught upon, start with that factor. Okay. Plus a1 upon s minus 2. In the second step itself, you are getting a linear factor. That's why you have to stop. Plus, what about the next one? This s plus 3 is the linear factor. So in the regular way, you can represent this as a b upon s plus 3. Okay. Now recall the formula. What is an minus 1? An minus 1 is given by 1 upon n minus 1 factorial into n minus 1th derivative of n1s, and value of this function at s is equal to a. Correct? Now what is n1s in this case? For our example, n1s is given by the given function 1 upon s minus 2 bracket square into s plus 3 multiplied by that factor. That means s minus 2 bracket square. You can notice that this n by s minus 2 is 1 upon s plus 3. Okay. Means in
Sir,
short, huh,
N1 S ची जरा स्टेप रिपीट करा.
okay, you have to find n1s in our case. Okay, right? This one. Now, here I will write. n1s काढायचं आहे तुम्हाला. बरोबर आहे? n1s काढताना दिलेला फंक्शन आहे तसंच घ्या. काय दिला मी? 1 upon s minus 2 bracket square into s plus 3. इथपर्यंत काय डाऊट आहे? I think no doubt, right now? Now for this factor, you have to multiply by द रिपीटेड फॅक्टर विथ इट्स ऑर्डर. काय आहे हो तो फॅक्टर? येलो कलरनं हायलाइट केलेला आहे.
minus 2 square.
s minus 2 square. And that factor you have to cancel. म्हणजे न्यूमरेटर आणि डिनोमिनेटर मध्ये सेम आलाय. What is the remaining? The remaining one is 1 upon s plus 3. I think it is clear.
Yes, sir.
Okay. Now in short, if you close this s minus 2 factor, remaining one. Now in this formula, you have to put n is equal to 1, where suppose a naught is given by, means in this formula, put n is equal to 1. 1 upon, tell me, 1 minus 1. बरोबर आहे? Into d by ds, order of the derivative is 0, into n1 of s. n1 of s किती काढलेला आहे तुम्ही आता? s plus 3. And value of this function at s is equal to, what is the value? You have to put जो काही फॅक्टर आहे डिनॉमिनेटरला, n minus s minus 2 equal to 0. So s is equal to 2. Value of this function at s equal to 2. Further, 1 upon 0 factorial is 1, and 0th derivative is nothing but that term itself, s plus 3. 0th derivative म्हणजे the term itself. Purposely I am using the bracket. And value of this function at s equal to 2. This implies that a naught is given by 1 upon 3 plus 2 is 5. Is it clear?
Yes.
Yes. Okay. Now next, in this formula, if you put n is equal to 1, then next, or n is equal to 2, a1 you will get. a1 is equal to 2 minus 1, 1 factorial, d by ds of n1s. And what is your n1s? 1 upon s plus 3. After finding the derivative, you have to put at s is equal to 2. So further, what is 1 upon 1 factorial? It is 1. Okay. Now derivative of 1 upon x, by that result, derivative is 1 upon x square. So its derivative becomes 1 upon s plus 3 bracket square, and value of this function at x equal to 2. So can anyone evaluate this? a1 is, this term is negative. 1 upon 3 plus 2 is 5, and 5 square is 25. Verify it. Is it right? Or not understanding? No response. Either write in the chat box. Is it clear?
Yes, sir.
Yeah. Okay. Next. Now we have calculated the constant a naught, a1. The remaining is b. Now b is in the regular way only you have to calculate. B is given by 1 upon s minus 2 bracket square into s plus 3 multiplied by s plus 3, and value of this function at s is equal to, can anyone help me to write?
-3.
Yes, very good. S equal to -3. Now here you, you can notice that this s plus 3 factor get cancelled. Okay. And if you substitute s is equal to -3 in this term, -3 minus 2, what is the evaluation?
Minus 5.
-5. And -5 square
25.
is 25. So b is given by 1 upon 25. Now, if you are using the regular method, then you are getting that simultaneous equations, and there is a chances to perform some steps wrong. That's why it will be better. This is new. That's why you may feel initially that this one is difficult, but once the formula is with you, directly you can find the constants. Therefore, L inverse of first one, that left side, 1 upon s minus 2 square plus s plus 3 can be written as L inverse of A naught is 1 upon 5 into s minus 2 bracket square plus A1 is minus 1 upon 25 upon s minus not plus s minus 2 plus 1 upon 25 s plus 3. Okay. Now further it can be written as by linearity property 1 upon 5 into L inverse of 1 upon s minus 2 bracket square minus 1 upon 25 into L inverse of 1 upon s minus 2 plus 1 upon 25 into L inverse of 1 upon s plus 3. So this one is given by 1 upon 5, and by using first shifting theorem it can be written as e to the power 2t into L inverse of 1 upon s square. I am right?
Yes, sir.
Minus 1 upon 25 into e to the power 2t. Okay. Plus 1 upon 25 into e to the power minus 3t. Now the last step, this is 1 upon 5 into e to the power 2t. What is this term? What is this term?
Square.
L inverse of 1 upon s square is t now only.
Yes, sir.
It is t raised to 1 upon 1 factorial. It can be written as a t minus 1 upon 25